Okay, the electrolysis has gone on very well, and what I'm going to do at this point now, it has filled the test tubes with gases. I'm going to turn off the power supply. Just press that switch. I'm going to take my wires away from the power source. If you were doing this in the lab, you would have been doing the very same thing that I'm doing here. You kind of disassemble it. Get rid of the electrical current flow first before you start touching things. Let's take these off the electrodes. Now the electrodes are in solution. I just have to take them out and rinse them off. But what I really would like to test now is how much gas did I get. Remember, this is the electrode that had come from the red terminal. Okay. And that should have a charge coming out of it. Could be plus or minus. And then the other electrode on this side for this test tube is coming out of the black terminal. And that's a different charge coming out of that. So let me lift the test tubes just a little bit to get them off the clamps. And we'll do it with this one too. I'm just letting the test tubes now rest at the bottom. Let me get the clamps out of the way. Let's take out the electrodes. I've kept the test tubes underwater because I want to capture the gases there and test them. And I want to also compare how much gas is in each test tube. And I'm going to bring the computer up a little closer so you can see here. Okay. The test tube that had the red wire coming to it is where my finger is. That's the volume of the gas we've trapped. The other test tube is a little further down, and again my finger is pointing to it. So the ratio of the amount of gases here is a little bit different, and it's pretty close to what we would expect it to be experimentally. There's a ratio of the two volumes to one another. Now the next thing I want to do is I want to take the gases and test them. And one of the ways that I can do that is with a splint or one of the aim and flame lighters. So let me take the test tube that has the most gas in it, put my finger on the bottom, trap the gas. So my finger's on the top, light the aim and flame and bring it over to the top of the test tube. And you heard that noise. That tells me that the gas that was trapped in this test tube was hydrogen gas. It pops, it explodes a little bit. Okay. For the second test tube, what I'll do is I'm going to get a wooden splint, and I'm going to take the gas that's coming out of here and bring a wooden splint over to it and test it. So let me put you on pause again for just a moment while I go get a wooden splint, and then we'll come back and test it. For the second gas, we tested already and had the evidence that there was hydrogen present there. The second gas, since we're breaking down water, this should be oxygen, and so we'll test and see what happens when we put a glowing, not a burning splint, but a glowing splint in the test tube with that gas in it. So let me retrieve the test tube, and here you can see the liquid level is not as far down as the hydrogen test tube. What I'll do is I'll try to get that gas, once I flip it over, to come to the top in the opening, and we'll test the presence of oxygen gas. So let's flip this over. I'll put my finger on the top. Let me light a splint. Splint is burning. Let's pull out the splint and get it just to glow. Then we'll test it, the gas on the inside of the tube. Glowing splint. Good results. Try it again. Glowing splint. and it barely relights. That first ignition you saw was the fact that the oxygen was present there. I was able to take the glowing splint, and it was not burning at that point, but caused it to burst back into flame. Fuel, oxidizer, so the combination of the two. So this is like a secondary test that we can do to prove what gases have been evolved. We can also compare their volumes, as we talked about how much is in the test tube. So here's the experiment complete now on the electrolysis of water. The idea is you take the water molecule and then you break it apart using electricity to break the covalent bonds, and both of those worked very well. Now I'm going to turn off the video at this point, move to another spot in the lab, and we will finish up with a couple more quick experiments. All of this again is found in your textbook. From this reaction you can eventually find a chemical reaction for the breakdown of water, write it down in your notebook, balance the equation. Eventually you're going to show or submit an image of your notes to your teachers today. Thank you. We'll be back. Okay, for our next reaction, we're over by one of the fume hoods in the lab, and there's a reason why I'm here, because one of the materials I'm going to be working with will probably produce a material that has an odor to it, and it also is somewhat irritating to your lungs, so I want to be cautious with doing that. The first experiment I'm going to be doing also gives off material, but is not as harmful to what we're going to test. So the first reaction I'm going to do here in this sequence is to just simply show a reaction of combination. And so I have a little tiny piece of magnesium ribbon here. It's metal. I'll bring it up a little closer to the camera. So it's pretty small. It's very thin. I'm going to put it into a flame using a Bunsen burner. And I just want to hold it here. And I got a pair of tweezers to do that, just so I got a good grip on it. Okay, so here it is stuck on the tweezers. Now let's light our Bunsen burner. And then we're going to take the magnesium and just put it in the edge of the blue cone and let it react. So once I gave it enough energy to start its reaction, it went all by itself. It has reacted with oxygen in the air and formed a new compound, which is kind of a white color. That new compound is magnesium oxide. It's very fragile material. If I were to touch it with my fingers, it would probably break off. Let me try to do that. I have a tray over here, and let's see what happens if I touch it with my fingers. At this point, it's pretty cool. Let me bring that up. It dropped off. If I touch it with my fingers, it now ends up being just a powdery white material. And it actually has some uses. The compound that I produced here has a use that helps neutralize acids, and in a couple of applications actually it can neutralize acids that might be in your stomach. And you can buy a product that is built on this reaction at the drugstore. It's called milk of magnesia, and when you buy a bottle of it, if you pour it out into a spoon, it is a white creamy liquid. Looks like real thick water. If a person had an upset stomach, they could take that, and then the compound that would be made from this would eventually neutralize some of the acid in their stomach. In our final reaction, which is set up here, I'm going to be taking an ordinary soup can, flipping it over to use as a little platform. And what I'm going to do is put some sulfur on this. My sulfur is in the powdered form. There there are ways you can get it where it's lumps. But I got a little bit of sulfur here. Place it on top of the metal can. The metal can is just a support to hold things in place, and this way I don't have to mess up a piece of lab equipment. I can just put the metal can through a recycling process when I'm finished. Now, to get the reaction to occur, here I'm going to use a Bunsen burner flame, and I'm going to aim it at the top of the metal can where the sulfur is. The sulfur that's here can combust. So the reaction you're going to see is actually two types of reaction. First of all, it's going to be a combustion, but secondly, it's also going to be a composition reaction. And the sulfur will combust or combine with the oxygen in the air and make our new product. This is the one that has the smell that I'm not really favoring, and it also has an effect on your lungs. So I'm going to turn on our fume hood. It takes a couple of, like about a minute to turn on. And eventually what I'll do is I'll light up my Bunsen burner, put it over top of the sulfur, and try to catch it on fire. And when I do that, I'll lower the sash on the fume hood a little bit so the air is coming and pulling the burning compounds, fumes away from us, or away from me. Now, that may take a second or two to react. So let me put the video on pause once again. So our sulfur is combustible. Here it is in the jar. I'm going to take the jar and get it out of the way. And then we'll light the burner. You can probably hear the sound of the fume hood. We'll tilt this a little bit to get the flame to go down on top of the sulfur, and I'm going to also move it back just a little bit. First thing that happens is the sulfur starts to melt. And you can see a white, probably see a little bit of a white smoke that's coming off of it. The sulfur is actually burning on top. I have the burner off now. I can see a slight blue flame here from the sulfur. I think I burned most of it out at this point. And the white smoke that's coming off is sulfur dioxide, which is very irritating to your lungs. The can is a little bit cooler at the bottom. Whoa, a little burning yet. I'll tilt it a little bit. There's no smoke coming off at this point, but we now have a residue from the melted sulfur on the top. And the white smoke that you saw was the sulfur dioxide going off into the fume hood. So this is an example of two reactions together, combustion and a combination. Again, you're going to try to look these up in your text. You will be able to find them in the text material, write their chemical reactions, and balance the equation. So that wraps up our experiments for today, and hopefully this is helping you see real situations and what you can do with equations and how you can put the atoms in equal proportion to one another. So good to be with you and show you this. I'll stop here at this point, and eventually you'll see this on the Moodle website.